what I'd like to do is sort of summarize everything that we've talked about today. And this can be done, I think, fairly quickly. And I'm going to talk about a systematic and comprehensive method for analysis. And it's really just a summarization of all the different techniques that we've talked about and where their value lies and how they all fit together. This is a little flow chart that discusses the different elements of production data analysis. Furthest on the left-hand side, diagnostics. We haven't actually touched on this yet. This is going to be the topic that I get into a little bit more next. But this is something that you'd want to do right on the front end. And we started immediately with the interpretation and analysis under the assumption that we had already validated and had done the proper diagnostics on the data. But I'm going to tell you that I think the diagnostic part may be the most important part, because if you don't critically look at the data from the beginning and do some very practical diagnostics, you may end up missing something very obvious. And I'll get into that and show some examples in a minute. But I'm going to say that this is very important. And what we're going to be looking at here is basically validation of the data itself. Does the data that you have make sense? Because it may not always make sense. There may be some problems with the data. And then we can talk about reservoir signal extraction. Reservoir signal extraction is really, okay, I've got this set of data. Hopefully there's something in there that's going to tell me something about the reservoir. But there may be lots of other stuff in there, operational changes and noise and scatter and this and that, things that aren't going to be helpful for my reservoir interpretation. So I'm going to try and filter that out and extract only what's valuable. So the diagnostics are kind of some upfront data preparation work, which I think always needs to be done in order to properly do the analysis from that point forward. Now the stuff that we really have spent a lot of time covering so far is the interpretation and analysis. And the interpretation and analysis, as I said before, that includes traditional Fetkovich, Blassingame, Agarwal NPI, flowing material balance, transient, all of these methods. And then, of course, the new methods that I didn't really spend too much time on, specialized in Wattenberger, haven't been added in here yet, but those are the new methods that we're using as we start to get more into tight gas, unconventional gas, and even tight oil systems. What we use all of these different interpretations for is basically identifying dominant flow regimes, and we talked about that, estimating reservoir characteristics, identifying important system parameters, and qualifying uncertainty. And all of those things together, really, they represent, as a reservoir analyst or production analyst, I'm trying to gain as much understanding about that reservoir and that well as I can using the data. And that's both qualitative and quantitative. I'm going to get some numbers out of it, but I'm also hopefully going to get an understanding for the dynamics that are going on inside that reservoir or inside that well. When I'm finished with that, I'm going to have some ideas about what's going on, maybe some results, and I'm going to want to plug those results into a model, as I said before, and this is where the circle comes in again. There is a lot of back and forth with this, and that's why I've drawn the arrow going back. For instance, you may have what you think is a good interpretation here, but then you put all the data in a model and it doesn't match. Well, then I maybe have to revise my interpretation. So that's where I go back into here and do this again and maybe find something else that's more consistent with the data. So everything has to fit. We can't have results here that don't work here, and vice versa. So everything has to fit with everything that we know about the system. And that's not only true inside, production analysis, but also external information. It has to fit with your understanding of the geology and the petrophysics. It has to fit with your understanding of the field and completion. It has to fit with your understanding of the fluid properties, the reservoir properties that we know from other disciplines. So everything has to fit together. Once we've accomplished this, we can move on, and then the final step would be production forecasting to determine reserves, to do optimization scenarios. Once we have a good analytical or numerical model, we can actually forecast under different constraints and different situations to predict how things may change if we try this or try that. or just simply to predict reserves, recoverable reserves under our current conditions. So that's usually the final step. Sometimes we're not interested in that. All we want to know is the permeability of the system. Well, then we'd stop here because we'd have that answered at that point. But that kind of represents a good flow for analyzing production data. But I want to point out that when you're looking at production data, try to identify your objective ahead of time. What am I trying to do? Am I trying to get a production forecast? Am I trying to understand what the reservoir permeability is? If you can streamline your approach, then maybe you don't have to do all of this. So this is sort of a very generalized approach. But it works quite nicely if I'm really just trying to get as much value out of the data as I possibly can.